This is another installment of the continuing series on best practices dealing with Excel and VBA focused on manipulating and accessing external data. This video is focused on cell references, primarily volatile functions, dynamic ranges, and then we'll talk about a particular problem you should be aware of with formula execution. This video is brought to you by PolarisInvesting.com, a site for creating defensible valuations. As a reminder, business valuation is based on expectations derived from skillful consideration of past facts and future possibilities. This series of videos is broken up to two kinds of videos. One is primarily on front-facing, that what we call Excel, what the user typically sees when they interact, and we use this analogy with the scoreboard at the baseball park. But also, the other set of videos deal with the back end of the scoreboard, which is more VBA. This presentation on cell references primarily is about front-facing kind of issues Excel issues deal with, but there will be some discussion of VBA back end as well. All right, the first major topic in this video has to do with volatile functions. Volatile functions primarily include the now function, which gives you the time, the current time, the today function, which gives you the date and the time, info, which gives you lots of different information about your spreadsheet, cell will give you information about individual cells, the random or called rand function that will create a random number. Offset will create a reference offset from a particular cell row coordinate, and then the indirect is used to reference this contents or value of a specific cell. All of these functions are what's considered volatile, and that means that whenever there's any kind of recalculation in your spreadsheet, these functions are automatically recalculated. And by themselves, that doesn't sound too significant, but these kind of functions can have severe performance impact on your spreadsheet because of the downstream references to the cells. So you do a calculation, these cells with these functions in them recalculate, and then all references to them and then references to those, and it just propagates through your whole spreadsheet. And so it looks like just a fairly benign thing to do in terms of pulling the current time or date has huge impact. I'm going to talk specifically a bit now about the offset and the indirect, because those are used a lot by different spreadsheet designers to go pull reference information in other cells, but because they're dynamic, you want to really avoid them. Now there's other functions here that seem to be related but are not volatile, namely row, column, and index. Row just simply returns you the row number of a cell, and column the column number of a cell. Index is similar to indirect in terms of its ability to pull a value from a specific cell, but it's not volatile. So what we want to do next is look specifically at the behavior of indirect, which is a representative of a volatile function, and the index function, which is non-volatile. And to do that, we're going to use this spreadsheet called RefTest. So this RefTest spreadsheet focuses on just two main types of referencing other cells. And so I'm using the index. You can see here that this makes an index. It makes reference to, or uses the index function call, makes reference to a data range on the data worksheet, and then it specifies a specific row 4 and then a column that it pulls from the E1 cell on the data worksheet. Now if we go over to the data worksheet, you can see here that E1 corresponds right now to column A. Now it can be set up so that we can change either this value in column A, or we can go to column B, but I'm going to leave it referencing column A. So we're pulling this value here, namely this is static or literal value 10. Now if we change it to column B over here, we'd be referencing a volatile function now, but in this video we're going to leave it just referencing a literal value in column A, namely the number 10. So now when we come over here and look at this formula, you see here that it's pulling back the number 10. Now over here to the left is the same index call, but now it's part of a larger formula. And right now we're setting the formula such that when we check for D3 equaling reference, it's just going to do this echo back function, which we'll take a look at here. That's a Polaris provided function for doing tracing function execution. But it will not, the formula does not result in this index function actually being executed. And so you can see here that it brings back the word reference, because in D3 is the word reference. Now down here in the indirect section, similarly, it goes after the same cell, but uses indirect function, which references to the data spreadsheet and then the column in row 4. And the same thing over here, the reference is the formula. Then there's the same indirect statement, but it's never going to be executed because of the the way that the formula works, and it's going to just bring back the value of what's in D3 through this echo function. Let's go now look at some of the VBA code to see what's going on kind of behind the scenes. So you can see here there is a function called Echoback, and it simply echoes back. You pass in a value, and it returns the exact value that you typed in. But then it calls a trace function, and the trace function is down here, and what it does is it takes the function name, and you can see here that when we call, we pass in the function name that's invoking the trace, and so then it'll come back and now indicate the function name, and this will determine essentially the worksheet that the function was called from, and then the specific cell on that worksheet. So it literally allows us to trace the execution of where this echo function is being called from. Now also notice there's a function called column number that takes a column letter and then determines the number. So like column A, this function would return a 1, column B would return a 2, so on. But notice it also calls the trace function. So if this function does get called, we'll see that the worksheet in the cell that called this function. Column letter is set up the same way. Now the way it works is if you enter a column number 1, it returns the letter A. Column 2, the letter B, but because it calls the trace function, it will show where what worksheet and the cell that called column letter. Now going back here to look at the calculations worksheet, you can see here that this cell in A7 does call both Echoback and ColLetter. And so we'll be able to see which side of the if statement did this, first of all, did the formula now in the spreadsheet get executed, and if so, which side of the if statement did it end up taking, Echoback side or the column letter side. Same thing up here, we have Echoback and now column number, so we can see if the formula gets executed and then which side of the if got executed. And then here we use column number, so we know whether this formula in the cell B3 got executed. And then down here we use column letter, so now we know whether this formula got executed. Some other VBA code that we need to be aware of is dealing with the worksheets themselves. And if we go up here and look at the data worksheet, it captures any kind of change event, and then it says, well, if the change event had to do with C1 changing, then it's going to pop up a message box that says, hey, look, there's been a change in cell C1. or if there's been a change in cell D1. So let's go look at that. And what these gray cells indicate, that's what the tests are going to be. We're going to see what happens when simply just clear the cell D1, do nothing to anything in this range that's being referenced in the index function calls on the calculations worksheet. So we'll see what happens when we make a change to a cell outside that range and inside that range, namely C1. When we start the test, that we know exactly what change event just occurred, and then see what the downstream changes are from that cell changing. Okay, so let's run a test here where we make a change here on worksheet data, and let's just clear cell D1, and then we'll clear cell C1. And the difference we should expect is that in C1 we're making a change by clearing cell C1. We're making a change in the range that's used by the index function, whereas when we clear cell D1, it's outside the range. And just so you see that here, over here to the left is, because we're not going to be able to flip back and forth, is a screenshot of the calculations worksheet that includes its formulas. So you can see here in formula B3, you're using the index function. You can see the range from A to C, so it references actually the this entire range here, and then it also references that same range in A3. But in A7 and B7, it uses the indirect function. It just references the specific cell, A4. All right, let's go ahead and clear in a range outside the area that's referenced by the index function and see what happens. Well, first of all, the echo function is called from cell A7. So if we go over here and look at the formula in A7, you look at, well, why did that happen? Well, you can see the logic of the formula is that if D3, which is equal to reference, it just calls echo back with the value in D3, namely reference. So yeah, we're seeing echo back called by A7. But why did that formula even, or that formula in that cell even get executed? It's because the indirect function is volatile. So regardless of what initiates the recalculation, volatile function is evaluated on every recalculation. So let's keep going further and say okay to that. Now we see that in result downstream to cell D1 being changed or cleared, we now see that B4 is being called on the data worksheet. And that's because in B4 is the now function. It's a volatile function. So next is B7 back on the calculations. Well, what is in B7? Indirect, volatile function. Now we're capturing the user change event, which is from clearing cell D1. Notice that the user change event always occurs at the end of the current calculations. Now notice the index related formulas in cell A3 and B3 did not get recalculated when a cell D1 on the data worksheet was changed. So now let's go over here and now change cell C1 just by clearing it. And the first thing we see is that A3 now the formula is calculated, and we can see here that because of the execution of the formula itself, it calls echo back. But the reason that this formula is even being executed is because of the index statement, that the cell range of A through C, we've made a change in that reference range. So it causes the whole formula to be evaluated, resulting in the true condition of the if statement to be executed. So now we look and see that A7 is calculated for the same reason as it was when we changed cell D1. It's just simply a volatile function. And we go to cell B4 on the data worksheet. Well, that's the now function, and it's volatile. Now you can see the column number, not echo back, but column number now got executed in B3. Well, B3, there is no echo back, but you can see here we used column number in the index statement. So since this formula is now being executed, we trace that by virtue of the column number, which is to be expected because we changed a value in the range of the index. Next we see B7, which was recalculated because it's a volatile function. And then you can see here that we're capturing that there was a change event here in C1. What are the conclusions we can draw from this test? Well, one is any formulas containing a volatile function are recalculated, meaning the formula is evaluated and true conditions are executed. But a second conclusion that's not really obvious is that, like it states here, formulas that reference cells that have been updated are recalculated regardless if the updated cells are in the current execution path of the formula. So up here we saw this formula get executed even, there was a change in this range of values, therefore the index is impacted, but it causes the formula to be reevaluated, and the true condition of the formula gets re-executed even though nothing changed in that part of the formula. Only the portion in the false condition actually changed. Now where that can really have a big impact is if you have a conditional statement, like an if statement like this, where the condition down here causes the true condition of the formula to be re-executed even though nothing in the true condition changed. If the true condition does a performance expensive operation like going out to the internet to pull data, this can have a huge impact on the performance of the spreadsheet. So just be aware that any changed value referenced by the entire formula will cause the formula to be reevaluated and the true condition to be re-executed. Alright, so far in this video we've discussed volatile functions and shown just or demonstrated clearly through the reference test that formulas containing volatile functions are recalculated. We also showed that even if you avoid using volatile functions, you still have this kind of unusual distinction between execution path and evaluation. That you may not think that the false condition of your formula would cause the true condition of the formula to be re-executed. But both the true and the false portion of any part of the formula that's impacted by a change, even if you're using index, will cause the formula to be re-evaluated. Since this video was originally recorded, a potential performance problem has been identified when referencing a range of cells like shown in this formula. In this formula, even though the cell range is across the maximum rows of 1 million, or more exactly 2 to the 20th, there is minimal performance impact because the formula is doing fairly trivial operations across the cells referenced. When more significant operations are performed, there is often a significant performance impact, as shown in this formula. Notice it uses the more involved operations filter, sort, and unique. To diminish performance impact, it's best to use an explicit range using the index function, as you notice in this formula. Note, the maximum cells in a row is 16,000, or more exactly 2 to the 14th. So best to use an explicit range using the index function when doing involved operations across cells in a row. Alright, next we're going to talk about dynamic ranges, how in formulas you can create dynamic ranges instead of having fixed ranges. Let's say from A1 to B15, you can alter your ranges. So the three main ways that you can have dynamic ranges in your function calls is you can either use the offset, indirect, or index. But offset and indirect are volatile functions, so should try to avoid those as much as possible. But if you are going to use them, the offset, you just simply specify a range and then you specify cell reference, and then you can even specify an offset from that cell reference. I'm not going to spend a lot of time on offset because I really don't advise using it, but it can be very useful in certain situations, and the trade-off between it being volatile and the usefulness of it make it such that you would want to go ahead and use it anyway, but it's fairly rare that you should use it because of the performance issues and the recalculation. Indirect, you can specify, just because it's all text, you can just change the text of where you want to start and stop in terms of rows or columns and that kind of thing. But again, it's volatile, so don't suggest you use indirect ever. And then the index, people don't realize that you can specify something like this as your range, and that contextually will work because the interpretation of the index function is context sensitive. So it's if it's used like this where a range is expected, it'll actually let you it'll interpret it as a dynamic range. You should know that index function has two forms, an array or a reference form. And an array form returns a value or an array selected by the row and column. Now, if you don't specify the row or the column, again, I'm just saying that you're no longer using it in the context of a reference. You're just using this left portion, let's say, somewhere to reference data. If you don't specify the row or the column, then you get back the entire column or row. But if you specify both a row and a column, you'll get back an individual cell. Since this video was originally recorded, Excel has introduced a new function called VStack. It allows you to, as its name implies, stack up multiple arrays into one array. Okay, the last topic in this video is the use of the index function to reference specific cells, and we're going to compare it to the hlookup and the vlookup functions, and then close up with a quick look at the new function that Microsoft is rolling out that's in beta right now called XLookup. All right, so up here we're showing the most versatile way to go grab a cell using a non-volatile function index. It's referencing just simply a range of rows and columns, and then within those rows, it's able to use a match. It uses a match function to go grab a specific value from a specific column out of those rows, and then for the column portion, it does a match across the row, assuming that row 1, let's say, has the column headings. So this combination of using a match on both sides is very flexible because it allows you to define a range, but not be constrained in any way about which column in the range you search or which row across the range you do to search for the in this case employees, or the columns you search for Microsoft. So this allows you to search for down the column for the word in this case column A for Microsoft, and then search across the row 1 for the word employee, and therefore you get exact row column of cell that you're looking for. Now we can get somewhat the functionality with like vlookup if we use the match function inside of vlookup, but the limitation of both vlookup and hlookup is that it's relative to the upper left hand corner of the search range. So if you're searching for Microsoft, it assumes that you're searching in column A, whereas up here it can be column A, column B, whatever column you want to search through. And then here in lookup, when you hlookup, when you're going across looking across a particular row, it's always going to assume that you're searching in this upper left corner, row 1, and then using the match function you can then go down and find a particular row, but you have to search for this employees across row 1. Well, the new function that Microsoft is rolling out called XLookup, what's compared to more normal use of vlookup and hlookup. When you do a vlookup without using the match, again, here you're trying to find the word find in column A, because it's vertical, you're looking down through the rows, and you're specifying a false parameter that says that you're looking for an exact match. Now it's relative. I'm looking for, and then it brings back the third column out of this range. So it's bringing back column C of wherever it finds it in the row where it finds the word find. But you can see here this is just very specific relative to the range that you're looking for. It's you can't specify a range like C to Z and then bring back column A, because you can't go to the left of the range. You can only go to the right of the range. Horizontal lookup has the same limitation. It's just now you're looking horizontally, and again you can't go higher than where you, let's say I started at row 4. I couldn't specify row 3, 2, or 1. I'd have to specify a row relative to where I started from. So XLookup solves that by now having what they call a search range and a return range. So you can specify exactly what range you want to look in, and then what range you want to bring back. In fact, you could even bring back more than just one column. You can bring back an array and not limited to like you are with currently with vlookup and hlookup. Now there are a couple other parameters that go on the end of XLookup, but if you don't specify them, it assumes false, and therefore it'll be an exact match. A nice additional parameter that you would be able to specify is value if the search criteria is not met, so it'll default to that. Anyway, this will be available sometime in Office 365, probably around Q1 of 2020. Since this video is recorded, the XLookup function has been released, and there's been some creative uses of it. A typical use of the XLookup function is shown here, where you're searching for a specific value, namely Apple, in the range of A2 to 85, and then if it finds it, bring back the result from B2 to B5. So in this example, it would find this first occurrence of Apple and bring back the value of 100. Now by default, XLookup searches from first to last, but there is an optional parameter that you could change that from last to first, which in that case it would find Apple here and return the value of 150. But let's say you weren't interested in just any occurrence of Apple in column A, but you wanted to make it conditional on some value in another column, namely here in column C. So let's say you're looking for Apple, but in the region West. So the way you do that is you would look for Apple, multiply it by looking for West in column C, and place that where you would normally just put the range A2 to A5, and then you would search for 1 or where that's true. Now how this works is that the range A2 to A5 looking for Apple results in a Boolean array of true-false. This range of C2 to C5 looking for West also generates an array of true-false. So when you multiply them together to create essentially an AND condition, you end up with a range of zeros and ones, and then in the XLookup function you look for the first occurrence of 1. And the value 150 from column B would be returned. Now you can also use the plus operator for OR conditions. So in the example shown here, you'd be looking for Apple in the first column A, or the first occurrence of West in column C. That would result in the value 200 being returned. Notice when doing the AND condition using the multiply, you end up with an array of zeros and ones. But over here when you use an OR condition, because you're adding, you end up with an array that has 0, 1s, or 2. Or if you did multiple ORs, you would have even greater than 2. But the thing to notice is XLookup finds the first non-zero match. Using a combination of multiply and addition can create a complex combination of AND and OR conditions. Note that instead of using XLookup function, you can use the match or XMatch functions in a very similar way, but instead of returning a value, it returns the number of the first row that meets the conditions. All right, this has been a video on cell references. Thanks for watching.